Hello everyone, welcome back to High School Tutoring. I'm your host Manny, and today we're going to be learning solving equations using friction. So if I quickly just load up a couple intro stuff. So friction, let's define it. So it'll depend on the nature of sliding materials. So let's say if you're doing metal on metal, that value of friction will change depending on if you change it from rubber to metal. You know what I mean? So it's proportional to the normal force, which is kind of meaning, so whatever your normal force is, that's realistically what your frictional force is, plus the actual force of friction, stuff like that. And in the coefficient of friction is A, so that's something like that. I don't know, not too much is needed for that. And so there's a constant value based on type of material. There's no units, so it's basically dimensionless. It could be used anywhere basically. And it's determined experimentally, so obviously using finding using tables and stuff of different objects' forces when they're applied to each other. And so it's the ratio of friction to normal force. So that's just something like that. And it is defined as the Greek letter mu, or it kind of looks like this. So if we look at the types of friction that I have here, we have static and we have kinetic. So you can see static is an inequality, because what happens is static friction is but if it's not moving or just about to move. So the only way for a value, or for this value to be true, I guess you could say true, because it has a less than or equal to sign, is if mu of static, so whatever the static of mu, and I'll explain that in just a moment of why these have different sub names, and then normal force multiplied by that, if that's greater than the force of friction, then that, or if that's greater than or equal to, that means the object will be in constant motion or is starting to accelerate. That's kind of the idea. And then kinetic friction is now an actual equal sign. So it's just kinetic friction is just when an object is already moving. So if the force of friction is equal to mu of subletter k, and that's just mu of kinetic, is if it's the same, if friction times mu kinetic times normal force is the same, then it will continue moving constantly. So also, let me just explain these subheaders. So static friction and kinetic friction are two completely different types of friction. Static friction generally will have a higher value. So let's say if kinetic was 0.4, static would generally either be higher than that. So let's say if kinetic was 0.4 and then static would be 0.5, that would be how you would see a problem. So in this next problem, I'll explain that 100%. So let's take a look at a little example. So we're looking at this: a wooden crate with a mass of 100 kilograms is at rest on a stone floor. The coefficient of static friction is 0.5 and the coefficient of kinetic friction is 0.4. So you can see how kind of like I explained that just then, where static friction is generally much larger than kinetic friction. So there's something there. And so let's take a look here at part A. So what is the minimum force required to set the crate into motion? So the idea of static friction, so we're now to set the crate into motion kind of means that we're going to be starting static or motionless, and we're going to try and get it so that the crate starts accelerating or starting to move, obviously. So if we take a look here, and I grab a pen really quick, and here we go. So we want to find the minimum force. So what we have our mass of 100 kilograms, so that's something there, and we're using our static friction of 0.5. So we can let's just make sure we remember that there. It's just having our static friction of 0.5, and I could just mark that there. Our kinetic friction is less than that, so we need to make sure we have those. So what you do first, since it is the ratio of friction and normal force, and it is dependent actually on normal force, the value of friction, and we're trying to find the actual value of friction to be able to find the minimum force. Let's take a look here. So if we do 100 multiplied by 9.8 to do the normal force. So if we just find that, so multiplied by 9.8, and that is equal to 980. I should have probably known that in my head, but so that means that the normal force is equal to 980 newtons. So if I just do Fn is equal to that, so now we have that value. So if we take a look at 100 kilograms, and you see here in our static equation, we're looking at it here, or our static inequality. The force of friction is less than or equal to mu static multiplied by normal force. So that just means whatever our value of mu times our normal force is, it is either larger than the maximum amount of than the actual friction force, or is the same. And in this scenario, we're trying to find what is the same. So if we just did our normal force of 980 multiplied by 0.5, representing our mu static, we are able to find what that value is. So otherwise, just multiply it by 1/2 or divided by 2. It's very similar. So that means the minimum force required is going to be 490 newtons to get the crate into motion. And the reason this works is because if we look at the inequality, our force of friction, so let's just represent that, is either less than or equal to 490 newtons. So that means that this is greater than or equal to the force of friction. So if it's the same, that just means it's in constant motion, but it's still moving. So, and if it's greater, that means accelerating. So realistically, setting the crate into motion would just mean that this value would have to be true. That's it. So for part B now we say the crate is moving, so that means we're now going to be using kinetic friction because the crate is already moving. What is the minimum force needed to keep it in motion at constant velocity? So if we take a look, now what we're using, obviously, we're going to have our F, now that we're using the equal sign, we're trying to keep it at constant. So these values just must be the same, which is why we know it's kinetic. And also, now we say that the crate is moving, so that also hints as to why we need kinetic. So if we take a look there, we're going to do the same thing, really, and it's not really changed. It's just instead of using 0.5 as our static, we're using 0.4. So that just means we'll do 980 times 0.4, and then whatever that is must be equal to the force of friction, or else it isn't true. So if we take a look there, 980 times 0.4, that is equal to about 392 newtons, or if we rewrite it, that means the force of friction is equal to 392 newtons. So this can never be incorrect, or else they would not be equal and it would not be a true statement. That would mean it would either be moving accelerating or decelerating, obviously. So let's take a look. So if 500 newtons is applied to the crate, does it move? Does it accelerate? If yes, find the value of the acceleration. So let's take a look at this now. If we're looking at our original value, so now if does the crate move, that question kind of implies that we're using kinetic friction. So if the crate is moving, if we evaluate if the crate is moving, yes or no, that would mean that we are that we're using kinetic friction. So let's take a look here. So if 500 newtons is applied, so we have our F applied is equal to 500. If we have that value, does the crate move? So if we take our kinetic value here, our kinetic friction value, using our kinetic mu, and let's take a look. So if we have 392, and 500 is definitely greater than 392, that means that yes, the crate would move. So that means now we know that the crate is moving. If these values were the same, it would still be yes. But otherwise, 500 is greater than 392, which means it is moving. So we're just finding the net force here, and we have 108 newtons as our net force. And if we're looking at this here, does it accelerate? So if we're looking at this net force is not 0, implying that it is accelerating. If the net force was 0, that would mean that it's at a constant velocity, and we've already established that it is moving, so it can't be no movement. So it does mean that it is accelerating. It is both moving and accelerating. We have now determined that. So now, if yes, find the value of acceleration. So that means if we have 108 newtons just here, and we're looking for the acceleration, if we take Fn is equal to ma, if we're looking at this value here, our mass we know is 100, so that just means it's 100a is equal to 108. And if we want to find a on its own, we'll just divide by 100. So that would mean that a is equal to about 1.08 meters per second squared. If 500 newtons is applied, the crate will have an acceleration of 1.08 meters per second squared, or 1.1. I'll just have both there just to represent it. And yeah, so that's really it. These examples, you'll see a lot of different examples where you're either finding friction, you even could find mu. So if you have to find mu here, you could see here, if we're given the force of friction of, let's just use 392 here. We wanted to find mu, and we have 980 newtons. So that means 980 multiplied by mu kinetic is equal to 392. So that would just mean we would do 392 divided by 980, and if we did that, we should get 0.4, or the value of mu. So there's a lot of different ways that questions will be worded for you to have to find values and stuff like that. But yeah, I hope you guys learned something a little bit and kind of enjoyed it as well, because this is a very new topic and a lot of people don't really understand it, and my goal is to help people out with this kind of stuff. So I will see you guys in the next video. Goodbye.